Good day everyone! We are here to present our project titled Posture Monitoring and Correction System using Arduino Uno and Force Sensing Resistor. In today's digital age, many people spend long hours sitting, whether in front of a computer, during online classes, or while using their phones. Over time, this habit often leads to poor posture, which can cause back pain, fatigue, and other health problems. Our project aims to address this issue by creating a simple and affordable system that helps monitor and correct a person's sitting posture in real time. Throughout this presentation, we will discuss how our system works, the components used, the processes involved, and its significance in promoting better posture and overall well-being. The Posture Monitoring and Correction System uses the Arduino Uno as its main controller. It was originally designed to use force sensing resistor to detect the pressure or force applied to different parts of a chair. However, since Tinkercad does not support FSR components, the team decided to use potentiometers as simulated pressure sensors for the virtual prototype. In this simulation, 3 potentiometers represent the left, center, and right sides of the seat. By manually adjusting the potentiometer knobs, the system mimics how pressure shifts when a person changes posture. For example, leaning to one side or sitting upright. When the posture is balanced, the sensor readings stay within the normal range. In this state, the system displays a good message on the LCD and turns on the green LED, indicating proper posture. If the person starts slouching or leaning too much on one side, the readings go beyond the set threshold. This triggers a warning system where the red LED blinks, the buzzer sounds, and the vibration motor activates, alerting the user to correct their posture immediately. The system also features a push button for recalibration, allowing adjustments for different users or sitting positions. Overall, this project demonstrates how a posture monitoring system can provide real-time feedback to promote healthier sitting habits and prevent posture-related strain or discomfort. To build the system, we use the following components: Arduino Uno R3, which serves as the main controller of the entire system. 3 potentiometers use as substitute sensors to simulate pressure detection that would normally be handled by force sensing resistors in an actual prototype. 2 LEDs, a green LED to indicate good posture, and the red LED to signal poor posture. A buzzer that produces sound when the bad posture is detected. A DC motor which provides vibration feedback to alert the user. A 16x2 I2C LCD used to display the sensor readings and posture classification. 1 push button for calibrating the sensors whenever needed. 220 ohm resistors, a diode, and a transistor to help control current flow and protect the components. A breadboard and jumper wires for connecting the entire circuit. Power through the Arduino's USB port. All of these components were connected and simulated in Tinkercad, allowing us to observe how the circuit behaves visually before applying it in a real setup. This is the circuit diagram of our project. As you can see, all the components are connected through a breadboard and controlled by the Arduino Uno. This board serves as the main controller of our system. It processes all the data coming from the sensors and controls the output devices. Right here, we have 3 potentiometers connected to the analog pins of the Arduino. These act as our simulated pressure sensors, which will represent the left, center, and right sides of the seat. They detect any changes in pressure, just like how the real sensors would sense if someone is sitting upright or leaning to one side. We also have two LEDs. The green one indicates a good posture, and the red one lights up when a bad posture is detected. Next is our buzzer, which gives a sound alert whenever poor posture is detected, and the vibration motor that provides physical feedback to remind the user to sit properly. Here's the LCD display, which shows the sensor readings and whether the posture is classified as good or poor. It is connected to the Arduino through the I2C interface, using only the SDA and SCL pins for communication. There is also a push button connected to the circuit. This is used for recalibration. It allows the system to reset or adjust for a new user or a new sitting position. All the components are powered through the Arduino's 5 volts and GND pins, with resistors and transistor added to protect the parts and control current flow properly. Overall, this circuit shows how different input and output devices are combined to create an intelligent system that can monitor and help correct sitting posture in real time. Now that we have introduced the project and the materials, we will explain the system's process and flowchart step by step. Let me begin by explaining how our system starts up. First, when power is connected via USB, the Arduino Uno microcontroller automatically begins program execution. When the system is powered on, it goes through system initialization, where all the components are set up and the pin modes are defined. After that, it performs auto calibration to get the baseline values for what's considered a good posture. Once calibration is done, the LCD shows system ready, which means the system is now running and ready to monitor posture. Now, in the main loop, the Arduino continuously reads the values from the 3 potentiometers connected to analog pins A0, A1, and A2. These readings represent the pressure or balance from the left, center, and right sides of the seat. The system then updates the LCD display and analyzes the posture based on those readings. If the readings are balanced, meaning the posture is good, the green LED turns on, the red LED stays off, the motor and buzzer remain off, and the LCD displays good. However, if the system detects an imbalance or poor posture, it triggers the feedback system. The green LED turns off, the red LED starts blinking or turns on, the motor vibrates, and the buzzer sounds. The LCD will then display poor as a warning for the user to correct their posture. After that, the system sends a serial output for monitoring and waits for a short delay before repeating the process. This cycle continues, allowing the system to monitor posture in real time. Now let's move on to the calibration process of our system. When calibration starts, the LCD first displays calibrating to let the user know that the system is setting up. Then, it takes 10 readings from the potentiometers to measure the current sitting position. After collecting the readings, the system calculates the average values and stores them as their baselines. These baselines act as the reference for what's considered a good posture. Once calibration is complete, the LCD displays recalibrated, meaning the system has successfully updated its reference values. Now, here's the optional button feature. The system continuously checks if the button is pressed. If it is not pressed, the system just continues its normal operation and keeps monitoring posture. But when the button is pressed, it runs the calibration process again. This allows the user to reset or adjust the system whenever they change position or when a new person uses it. After recalibration, the system simply goes back to the main monitoring loop, ready to check posture again using the new baseline values.